Hello, very good evening, students. Welcome back to our e-learning session. And it is initiated by Vidyadis Vidya Sankul under the guidelines of Dr. G.M. Sutaria sir. See, in our last lecture, we complete illustration number 11 and 12. See, 12th illustration is somehow very big, and see, it contains 4 marks in your final examinations. Okay, so it is very important, so please read that and write again and again in your exam in your rough book for your practice. So here we complete in our example book illustration number 12 and also complete exercise 1.1 and exercise 1.2 question number 1 and 2. Okay, I hope you all complete this. If not, please complete right now. Okay, now we will discuss about the main regular practical questions regarding probability right now. Okay, in this lecture up for that is illustration number 13, 14, 15, all this. Okay, shall we start now? Standard. Okay, so I am reading that particular question first. Find the probability of getting R in the first place in all the possible arrangements of each and every letter of the word Rutva. See, it is a question of permutation and combination. See here up to this, here the selection is there, and that's why we are taking NCR formula, that is combination. Now, in this question, Rutva word is given and you have to arrange all the letters of that particular word, that is R, U, T, V and A. 5 words we have to not select from that, we have to arrange the words. That's why here we have to use the permutations, not a combination. Okay, whenever the selection are there, we have to use the combination. Whenever the arrangement are there, we have to use a permutation. Okay, so here we have to arrange all the 5 letters of the word Rutva here. Okay, so here we start that illustration number 13. The word given is Rutva, 5 letters, and all letters are different. See, we have to arrange the data, that's why here we have to use the permutations, and here 5 letters are there, and for that 5 places are there. That's why we can say that total outcomes of this experiment is here n is equal to 5 letters are there and 5 places. This one is there. See, first place, second place, third place, fourth place and fifth place. 5th places are there. 1, 2, 3, 4, 5. 5 place and 5 letters. That's why we have to arrange the data. That is 5p5. That is 5 factorial. That is 5 into 4 into 3 into 2 into 1. It is 120. Okay, so here total outcomes of this experiment is 120 because there are 5 letters and 5 places are there for the arrangement, and that's why total outcomes of this experiment n is equal to 5p5, that is 5 factorial, that is 5 into 4 into 3 into 2 into 1, that is 120. So the total outcome is 120. Okay, now see that total number of outcomes n is equal to 120, 5p5. Okay, now event A. We have to arrange getting R in a first place. See, we have to write down R in a first place, that is here. In the remaining 4 places, we have to arrange all other 4 remaining 4 letters. So here first place, on the first place the word R is fixed. That's why here we can say favorable outcome of event A, that is M is equal to, here in the first place R is fixed, 1 letter 1 place, that's why 1p1. R is 1 letter and the place is first, it both are fixed, that's why 1p1. And for the remaining 4 letters, remaining 4 places are there, that's why into 4p4. R is on a first place, that's why R is a fixed letter, that is 1, and the place is also fixed, that's why 1p1. Okay, so for arranging R on a first place, the arrangement is 1p1, but for the arranging all the remaining letters, that is U, T, V and A, all remaining 4 letters and remaining 4 different places are there, that's why 4p4. This 4 is for letters and this 4 is for places, right? So 4p4. So here the answer is 1p1 is equal to 1 and 4p4 is equal to 4 factorial. Here 1 factorial is equal to 1. So 1 into 4 into 3 into 2 into 1, that is 24. So your M is equal to 24 here and N is equal to 120. And now we want the probability of getting R on the first places, that is P of A. P of A is equal to M upon N is equal to 24 upon 120 is equal to 1 by 5. 24 ones are 24, 24 fives are 120. That's why the total probability of getting R on a first place is 1 by 5. Required probability is, therefore we can say required probability is 1 by 5. So this is very simple. For 2 marks sum, please write down this. And here we have to know that about all these things, that here we have to arrange the data. The new thing is only that here we don't have to select the data, we don't have to select anything from that. We have to just arrange the word Rutva. In that particular word Rutva, we have to arrange R on a first place and then 4 remaining letters in different remaining 4 places. So favorable outcomes for that is 1p1 into 4p4, and that's why it is a 24, and here your probability is ultimately 1 by 5. So please write down this. Now the next question, that is illustration number 25. Four male employees and 2 female employees working in a government department are sent one by one in a turns to the training centers for training. See, total 4 male and 2 female, total 6 members, right? 6 employees are there in a government department, total 6, but it is turn by turn, one by one, all the employees are go for the training, right? Okay, next, find the probability that the 2 female employees go successively for the training. That means one female employee is go on the for the training, then and the other side next one is not any male employee. We have to compulsory send a female employee for the training in the next. That means here 2 female employees go successively for the training, one after another, both, right? So we have to take 2 as a one group. Here again the arrangement is that, see, it is not any selections for 4 male employees and 2 female employees. We don't have to select any male employees or we don't have to select any female employees. Here the arrangement to go for the training is there and we have to arrange them. Okay, so here again the problem for arrangement, not a problem for selection. Okay, so here we have to use compulsory permutations, not a combination. Please keep in mind. Please see here in the question there is no any specification regarding selection, no any specification regarding arrangement. Okay, we have to know about that. Then whenever we are seeing, whenever we are reading the question, we have to please be alert. While reading the question, we have to compulsory know that in this question we have to arrange the data or we have to select the data. After that we can take n is equal to 5C5 or 5P5, right? C for the selection, that is combination. P for the permutation, that is arrangement. Okay, so first of all read your question carefully and then find out whatever we have to take here. We have to select the data or we have to arrange the data. So after that we can say which sum we have to do, we can do that. Okay, so please keep in mind all these things. Okay, illustration number 14. Here 4 male employees. 4 male employees. I am writing M1, M2, M3 and M4. For 2 female employees, I am writing F1 and F2. Total 6 employees are there. And what is the total probability? See, total number of outcomes. N is equal to what? Total 6 employees are there and we have to arrange them in a 6 different ways after one by one. That's why here we have to take 6 employees and the places are also 6. See, first place, whenever first employees are go for the training, second, third, fourth, fifth and sixth. So total 6 places are there. One by one employee has to go for the training. Okay, so there are 6 places are there and 6 employees also are there. That's why we have to arrange the data in a 6p6 ways. Okay, now 6p6 is equal to what? Is equal to 6 factorial and is equal to 6 into 5 into 4 into 3 into 2 into 1. That is 720. So total n is equal to n is equal to 720. Okay. Total outcomes is equal to 720. Now, the main condition for event A. What is your event A? Event A is that the two female employees are go for the training successively compulsory, right? So here we have to say that event A is equal to what? Consider the two female employees going successively for the training as one person. Okay, here see that whenever F1, F2 both are, we have to select a one person. Then what? Then M1, M2, M3 and M4 are different 4 person. So total arrangement we have to arrange by 5P5 way, because whenever one female employees go for the training, we don't say that here between that two one male employees go for the training, because the condition is that two female employees are go for the training successively compulsory. Okay, that is our event. So F1 and F2 both are combined compulsory. It we have to assume it is one person. See, I want to say what? M1, between M1 and M2, F1 F2 is the M2, then M3 and M4. These are the one arrangement. See, these different types of many arrangement are there, but I am writing here one or two. M1, then M2, then again F1 F2, then M3 and M4. See, whenever the female employees are go for the training, it is compulsory successively. Okay, so we have to arrange them, we have to assume that as a one person. Okay, so here 4 different persons are there, M1, M2, M3 and M4, and F1 and F2 are one person. That's why total arrangement, if we want a training, we want an event that the employees go for the training successively, both female employees, then we have to arrange that in a 5 different ways, that is 5P5, that is 5 factorial. Okay, so here I am, please write down this for your understanding, not for your answer. It is your rough work. Please don't do this in your example book. Okay, it is your rough work. I want to explain you this because two female employees are successively go for the training, and that's why we have to assume at one person. Here it is a one person and the 4 different male persons are there. So total 5 persons are there, and that's why 5P5. The total arrangement is 5P5. Okay, these are the examples. Much more examples are there. Okay, so I'm not writing all, but here I'm just giving 2 more examples for this. Here first example, this one is second, this one is third. Here we can take this here between these two also, and here this one we can take at the end of this, that is M1, M2, M3 and M4, then F1, F2. Okay, so here we can arrange these in a very different ways. So please write down this. I am removing here. See, now we are writing that two female employees go for training successively. That is your event A, right? Now, favorable outcomes. Of event A, that is M is equal to, see, we have to see that one is F1 and F2 is a one person and the four remaining persons are there. That's why we have to arrange the data, that is 5P5. Total 5 persons are there and we have to arrange them in a 5 different places. That's why 5P5. But these two employees, that is female 1 and female 2, can change their order also. That is for F1 or F2, we can say that F2 and F1 is the different order, right? So here 2P2 for that, 5P5 for this one, F1, F2, M1, M2, M3 and M4. This one is a one person and this one is the remaining 4 person. That's why we have to arrange the data of 5 persons in a 5 different places, right? So here 5 persons for 5 places, that's why 5P5. But here the arrangement may be changed if F2, F1, M1, M2, M3 and M4. Again, this is a 1 person plus 4 persons, so 5. So here for this and this 2P2, the different way here the change vice versa, right? So when F1 and F2 are there, that's why we can say F1 and F2 and F2 and F1 different arrangements are there. That's why 2P2 for the interchange and 5P5 for these 5 person, 4 total person and 1 group, that is 5 person. That's why 5P5 for the total arrangement and the interchanges is the second way. That's why 2P2 is there. That's why we can say the total outcome, favorable outcomes of this data is 5P5 into 2P2. That's why 5 factorial into 2 factorial, that is 120 into 2, that is 240. That is your M is equal to 240 and your N is equal to 720. Now your P of A, that's why P of A is equal to M upon N is equal to 240 upon 720 is equal to 1 by 3. And that's why required probability is equal to 1 by 3. Okay, so this is a sum of permutation, that is arrangement 1, 2, 3, 4, 5, 6. 6 employees we have to arrange in a one way. That is, one employees go for the training, then the second, then the third, then the fourth, then the fifth, and then the sixth. But we have to, the main event is that we have to say that compulsory F1 and F2, 2 female employees. We have to keep in mind 2 female employees are go for a training successively, compulsory. That means here we have to take them as a one group, okay, and one group and 4 different players, 4 different employees, total 5 employees. That's why 5 employees we have to arrange in a 5 different way. That's why 5P5 and 2 employees, that is female employee, interchange. For that interchanging 2P2 is there. That's why 5P5 into 2P2 is the favorable outcomes of event A, that is 5 factorial, 2 factorial, that is 120 and 240, and that's why P of A is equal to M upon N is equal to 240 upon 720, that is 1 by 3. So your required probability for this is 1 by 3 and it is again only 2 to 3 marks up. So please keep in mind all this sum. See, in this chapter, one plus point is that no questions regarding out of this syllabus, or you can say out of from your book, that is from chapter number 1, no any different questions or other question will ask. They directly ask the specific example or the exercise sum. Okay, no change in any question. So please do these sums again and again, and remember this sum. Whenever this sum is there, you have to write this only and you can get full marks. Okay, so please write down this compulsory. I am giving you here 1 or 2 minutes for that. Okay, example number 14 is over. Now example number 15. Now the most important question, and it is very simple question, but you have to understand by these different way. Please keep in mind here what is the question. First, see the question, illustration number 15. It is very important. Find the probability of having 53 Thursday. 53 Thursday. See here the day will be changed. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. Anyone, right? But all the day the answer is same. If 53 Thursday other than 53 Sunday will ask, the answer is same. Okay? 53 Thursday in a leap year. So first of all, illustration number 15. Total number of outcomes, n is equal to how many days in a week? First of all, here we want Thursday, 53 Thursday for in a leap year. But how many days in a week? First of all, we have to know that 7 days. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Okay, so 7 days. From that, Thursday will come how many times? Only one times. Okay, so total number of outcome is 7C1, that is 7. Why? In a week, how many days? 7 days in a week, and from that we want only Thursday. Thursday is only once in a week. That's why from 7C1 we have to select, not arrange. See, we don't have to arrange Monday, Tuesday, Wednesday, Thursday. We just have to select 53 Thursdays from a leap year, from 366 days. Leap year, in a leap year there are 66 days. In a normal year there are only 365 days. Okay, so here total number of outcomes n is equal to 7C1. Why 7C1? Here 7 days in a week, right? And from that we want only Thursday. That's why that is comes in a week once. That's why 7C1. That's why 7 is the total number of outcomes. Now see that here total days in a leap year, it is always 366, right? Compulsory. In a normal year, if the question is not for the leap year, then what? Total days, I am writing here, total days in a normal year is equal to 365. See, which year is a leap year? First of all, the question is which year is a leap year. So we can say here 2004 last 2 digit, 2008 last 2 digit, 2012 last 2 digit, 2016 last 2 digit, and current year, that is 2020 last 2 digit. If last 2 digit are divisible by 4, right, there is no answer in fraction. There is full integer answer divided by 4. 04 divided by 4, answer is 1. 08 divided by 4, answer is 2. 12 divided by 4, answer is 3. 16 divided by 4, answer is 4. And the current year 20 divided by 4, the answer is 5. So last 2 digit of the year, if we are divided if it is divided by 4 and the answer is integer, then it is a leap year. And if the answer is in fraction for 2013, for 2018, 2019, last two digit, if it is divided by 4 and the answer is in a fraction, that means here it is a normal year, here 365 days and here 366 days compulsory. In these 5 years, the answer is total number of days in a year is 366. Here the total number of days in this year is 365. Why? Here in this 2004, 8, 12, 16 and 20, February has a 29 days, and in this year February has a 28 days. Only one day is increased in these years in February only. Okay, here we don't have any specification regarding any February, so we don't have to consider that. But whenever the February is given, 28 days and 29 days in a February. In these years 28 days, in these years 29 days in a February. So please keep in mind here in the exercise, see the sums regarding regarding the days of the February is given, and at that time you have to keep in mind all these things. In these years, please write down, in these years February has a 29 days, in these year remaining all the years, here the February has a 28 days, and from that we can find out these 53 Sundays, or here in February 4 or 5 Saturday, Thursday, Friday, whatever the day is there. Okay, here total 366 days and 365 days. But now please come on over our illustration. What is that? Total days in a leap year is 366 days. Now here in a 1 week, how many Thursdays are there? Only once. So how many weeks are there? So the answer is 52 weeks are there compulsory in each and every year. That is in a normal year or in a leap year. Minimum 52 weeks are there. How? See that here. This is not your answer. This is just for your calculation. Total week in a year. Full week. Is equal to 365 divided by 7, or you can say 52.14, or here 366 by 7, you can say 52.28. Okay, so here full 52 weeks are there compulsory. So this is not for your calculation, this is just for your understanding. Total days for full 52 weeks is equal to 52 into 7, that is 364 days. See, total 52 weeks are full from Monday to Sunday. All the days 52 times are repeat in 1 year compulsory, because total full 52 weeks are there in a year, in each and every year, in normal year or in a leap year, because the 52 weeks into 7, that is 364 days. In a normal year there are 365 days, in a leap year there are 366 days. So 364 are from that, that's why we can say 52 week full are there in each and every year. So 364 days. Now here what is the question? Here 2 days are remaining. In a leap year there are total 366 days, but we want full normal 52 Thursday. See, we want 53rd Thursday, because here 52 weeks are already there. So Monday to Sunday, all the 52, all the days are comes in a year 52 times compulsory. Sunday 52, Sunday 52, Monday, 52 Tuesday, 52 Thursday, and so on, right? So here full 52 days are there in each and every year, but whenever the questions regarding 53rd Monday, 53rd Tuesday, 53rd Thursday, whatever, we have to calculate that how many days are remaining here. Therefore, remaining days is equal to 366 minus 364, that is 2 days, right? Remaining days is 2. 52 times each and every day are there comes compulsory. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, all the day 52 times. We want 53 Thursday. That means here what are the remaining days for a leap year? In a leap year there are only 2 remaining days. 52 times all the days are come. Now 2 remaining days are there, and from these 2 remaining days, one Thursday is our probability. Okay, so event A is equal to 53rd Thursday. Okay, 53rd Thursday. So favorable outcome. For event A, M is equal to, from these 2 days we want one Thursday. Remaining 2 days. From these remaining 2 days we want one Thursday. Okay, so 2C1, that is 2. Therefore, your probability is equal to M upon N is equal to 2 upon 7. So your required probability, therefore, two by 7. Okay, so there are minimum 2 days remaining here in a leap year. See, it is, if not is a leap year, then only 1 day is remaining. 365 minus 364, that is 1 day is remaining. From that 1 day we want that particular day as a Thursday. So here 53rd Thursday in a normal year 1C1, 53rd Thursday in a leap year 2C1, that's why 2 by 7 is the total probability. And in a normal year, if it is asked in a normal year, then here 1C1, that's why 1 is your M, and that's why 1 by 7 is your required probability if the question is asked in a normal year, not in a leap year, but in a normal year. If the question is asked for the normal year, your answer is 1 by 7, your required probability is 1 by 7. If the question regarding leap year, then your answer is 2 by 7. Okay, so here complete your illustration number 15. Please write down this. Compulsory, and sums regarding this is in your exercise. So time for homework. Exercise 2.2, sorry 1.2. Question number 6, 7, 8, 9, 10, 11 and 12. Total 6 questions, not 7 questions. 6, 7, 8, 9, 10, 11, 12 is regarding illustration number 13, 14 and 15. So please do these all the sums. The word random is there, the word orange is there. 8, 9, 10, 11 and 12. 12 is for 5 Thursday in a month of August in any year. So please write down these sums in your exercise book, and you have to write down 15th illustration in your example book. Okay, so here I am complete my lecture. So thank you class.